Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, welcome. Today we have with us Adam Fraser, who is up in Crested Butte, so we get to do another live in-person podcast. And so, Adam, you can tell me your actual title, but I, of course, know you from ZIO, Scala ZIO, which Bruce and Bill and I are writing a book about. Bill Fraser, also Fraser. Do you guys spell your last names the same?
Spell them differently,
Okay.
So maybe long-lost relatives.
Yeah, nice.
Is a Fraser? You know, it's like there was a Smith who would do this. What's a Fraser?
Yeah,
I think it came from Scotland at some point, but I don't know much more about the origin.
You're probably involved with making beer or something.
Yeah, that sounds right.
Our Scottish listeners will complain about my typecasting them.
Yeah.
Or not. They might go, yep, that's us.
So Adam, I know him from his work in ZIO and primarily around all of the things you've been doing with the ZIO 2 runtime and making it just super awesome. I'm sure we can get into that. But I don't know. Tell us what you do. Everything ZIO kind of.
Yeah, that's not a bad description. So I started Zyverge with John.
You're a co-founder.
So it was just the two of you.
John, Sandra, and Itamar.
Okay.
So yeah, the four of us.
Okay. And did you have a customer? Did you have a customer at that time? Is that how you were starting it, or was it just supporting the open source project?
It was. We saw the opportunity, but at that point we hadn't even done the 1.0 release yet, and we were already seeing companies that were using it in production. So it seemed like we were really onto something there, and we wanted to do something to really build on that and take that to the next level.
Okay.
And how long ago was that Zyverge started?
So about almost 2 years ago. We did the first announcement at Functional Scala in London in 2019.
Nice.
Yeah.
I didn't realize it was that recent.
2 years. Yeah.
Time has maybe moved differently with the pandemic and everything.
That, and it seems like we keep track of time by markers, like milestones, and it seems like there's been so many like markers in the world of ZIO. Like it's just like, oh my gosh, another amazing library or another amazing release or another amazing talk or whatever it is. Like there's been so many markers that it seems like 2 years of calendar time is like 10 years of events.
It's 2 years of sprinting. Yeah.
Yeah. Yeah. So, I don't know. Yeah. Tell us about your history with ZIO. Like, how did you get into it? And
yeah, so I started out, I had been doing my own Scala stuff, just basically on my laptop for a while. I was doing finance and investing at the time and kind of trying to marry the fundamental with the algorithmic. And so developed a bunch of tools for myself to do that. And I had my own like mini effect system and things like that.
Wow.
But it was probably not the most sustainable thing because time you spend working on that is not time you spend actually looking at the things you're investing in, and there's a balance there. So at a certain point I decided, hey, if I want to do something with this, I gotta get it, not just be doing it myself, but I gotta start working with a broader group of people. And so I think I did my first contribution to ZIO probably like July 2019, something like that.
Okay.
And I think I did one of the symposiums where I was talking about open source, and I actually went back to that PR. And I mean, it's a very basic PR. It's one of those ones where someone had like scoped out like, well, here's exactly what needs to be done. Here's basically the code you hopefully copy and paste in, and this should.
It's kind of like you remember the draw by numbers. It was kind of like, oh yeah, from this number to that number.
Yeah. So it was an easy one, but
it seemed like it would be easy.
Okay.
But I did it, and there were complications because it involved parallelism and concurrency and all this fun stuff. And very quickly, like I got comments from John, I got comments from Itamar, and we had a lot of back and forth, and we got it in. But I could see that there's a real focus on correctness of it wasn't just like, is this okay, but is this the best way it can possibly be? And I think that's my own approach. So I think finding other people that have a similar
culturally
approach.
like your values aligned with John and with Itamar.
And it was also fast. I think that's one of the things I noticed is when there's a problem or when we say we want to do something, things get moving. It's not like there's something that's just sitting there for 4 weeks and people are like, oh, do I think this? Do I think that? Or like, okay, we got to make some decision here. It's the wrong decision. We got to move forward.
Of course, you were working with a fairly small group at that time. Because one of the things that we have been pondering is like, well, what is it? When you all agree? Consensus. Okay. Because I've gone back and forth with consensus. And it's like, oh, actually, consensus is good if you have just a few people, but it doesn't scale. And so that's when people start running into issues, is when you start getting more and more people involved. And then consensus is hard.
Yeah, and then you just go to the benevolent dictator because consensus doesn't work
just
anymore.
Like
so yeah, just like that. Yeah, unless you're the Apache Foundation, and you try to stick with consensus. But then there's a lot of fireworks.
See what happens. Yeah.
So you'd probably been doing Scala for a long time then, before.
So it's about 2014. Yeah.
Okay. Yeah. And do you have a background in like Haskell or?
Scala was pretty much your first.
I mean, I did a tiny amount of Java first, and then I moved to Scala. And so if you looked at my old code, you could definitely see like it started as a Java with semicolons, and it went from there.
Yeah. I remember that's how I started too. It was from Java to Scala, and I wrote my Scala Java without semicolons, and now I'm like full on ZIO like effects, pure functions, like that whole world. What about math? Do you have a background in math?
I studied chemistry and philosophy as an undergraduate, so I got some of it, but I'm definitely not a mathematician or a computer scientist. Yeah.
Huh. So cool to like go from not the Haskell world into ZIO, because it seems like obviously John and I don't know about Itamar or others, but like it seems like there was kind of this pull from that direction. But I think it's so important to have a different perspective, and I think it's probably part of what's made ZIO great is that it's not Haskell, and I could never really get into cats. It's like it was too. Cats and even Scala Z were just too far from my realm of what I was familiar with, and ZIO was the first time where I'm like, oh, this is something that I can do.
I remember I think it's when we had like a Scala summit or something. We all tried to watch one of the ZIO, not ZIO, Scala Z presentations, and I wonder now if I went back and watched it, if any of it would make, because none of it made sense to me. It was just totally I guess it was an introductory or something, but I wonder if I would grasp more of it now, or if it would still be hard to.
I would grasp more of it now, but I was the same way. I was coming from a Java background, all these ideas of like applicatives and functors, like all of it just was like, I don't even understand.
Is this programming or is it something else?
So that was where it started, and then you've done a whole lot since then in terms of like the runtime and the API, like surface layer, like what developers use, and I don't know, tell us more about what
well, I started out really working on ZIO test. That was the thing I got most involved with at the beginning, and I think it was a good time for me because that project was really just starting out. And so at the beginning, I always tried to take just about every pull request or take every issue that there was for ZIO test. If it would come up, I would take it. I would try to do it the next day or so, and I would take another one. And I always, when I'm giving people advice about open source, I always suggest that they try to find something that they can take ownership of. Maybe it's a whole library, or maybe it's just like this data structure, but take ownership of that thing. Of obviously you're not literally owning it, but you're going to be the responsible person there. And if there's an issue there, you're going to do your best to come up with a solution or bring people together to get to a solution. And I think that way you build expertise and you build value that you're bringing, where people are then coming to you and being like, hey, I want this extra thing. How can I do it? And then you give yourself a base to branch out from. Whereas I think some people just do a little bit here and there, which if you want to, that's fine. But I think you can maybe find it more rewarding for yourself as well as have more impact if you find something that
you can really immerse yourself.
Yeah, exactly.
Yeah.
Oh, and something that people like know you for and will go to you for, like this, that you, like you said, you own. When you own a piece, then yeah, it's different. So
yeah, and then you can branch out from there over time.
had you done much open source before this?
No, I done almost nothing.
Huh.
Yeah, I think I did one thing to Scala check way back, and that was about it.
Wow.
Yeah.
I mean, wild to go from like no real open source contributions to contributing to like one of the most, in ways, like hardcore like Scala libraries you could possibly find, and contributing like difficult pieces, like anything around concurrency, I'm sure is not easy.
Yeah, well, I think that's one of the things that is a real testament to folks like John, is at the beginning he spent a lot of time, like you would do a pull request and there would be very detailed feedback. Wow. And you incorporate that and you learn from that, you really get a lot out of that.
Yeah, and grow in your own understanding and ability to then go further. So yeah, we had Weem on a couple episodes ago, and she said very similar things about John's mentoring and how it had helped her, but also maybe that's part of what's made ZIO great, is that John has mentored people well and helped them become significant contributors to the project. So what are some of the ZIO parts of ZIO that you've worked on since Scala Test? Sorry, ZIO Test.
No, it's okay. We can just replace one with the other. So I did the Z-Hub concurrent data structure.
Okay.
And then I did the scheduler for ZIO 2.0, the Fiber scheduler. And
that was, I think, your most recent presentation I watched was about the ZIO 2 scheduler, and I'm just like, amazing. Like, there's some really hard problems that are underneath all that.
There's some interesting stuff there, and there's actually more coming.
Yeah, awesome.
So yeah, a couple of those big things, and then I find it's always a balance of there's those big things, but then there are also just the little things of a lot of what I think about around open source is just continuous improvement, and you have a lot of things of just make type inference a little bit better on this method, make this thing a little more efficient, add something that's going to make it a little easier to do this. And if you just keep going in the right direction consistently, that really adds up over time.
Yeah.
We've had some impressive surprises when playing with ZIO 2 and some of the error messages and inference that it's done. And it's like, how can it know that?
Yeah, there was
just not used to it in other languages.
Well, just like the error message we got on the layers that we were looking at, and how it's like, whoa, how did they produce such a precise and helpful error message?
Kit did a really good job with that.
Yeah, we were looking into like how that was actually implemented with like implicit not found or some amazingness. But yeah, to put effort into the developer experience, I think that's something that ZIO has done a really good job of, is investing in the developer experience side of things that most a lot of people don't put. They're like, it works.
Yeah, well, it's hard enough to get it to
wonderful
work
to use
versus, what's the experience that somebody's going to have? Can they just cargo cult their way into using this thing and get a good result? Which I think is a big, benefit. If I can I go, I wonder if this will work. And it'll go, no, that won't work because these reasons. Do this. Wow. That's really helpful.
Yeah. The developer experience is something I've been very, very pleased with using ZIO. And even we're mostly using it now with Scala 3. And I have realized how IntelliJ, I just can't even write code anymore without IntelliJ. That's kind of sad, because I used to be able to write a lot of code in VI. And now it's like I'm so dependent on IntelliJ. But IntelliJ in Scala 3 has not been super awesome.
You've been on the bleeding edge.
Yeah.
So for everything,
it's been interesting to kind of struggle through not having a very functional IDE. But even with that like huge hit to the developer experience, it's been such a joy to use ZIO. Like things we were talking with Bill about the in ZIO2, the naming of the methods. Just like when I go to try to find something,
you can guess.
Like, yeah,
guessability.
Yeah, the guessability.
Which is like you realize, we're doing this all the time, but they're not thinking about that normally. So if somebody actually thinks about, can we make this more guessable? Really helpful.
Yeah. And then so there's the guessability part that was really important, but then also consistency in naming.
Yeah.
So they're like in ZIO1, it's put Sterling and
it's the Haskell's
and readline. Oh, is that from Haskell?
That's exactly where it's from.
Oh, it's interesting to understand the history of that.
Mm-hmm.
Yeah, but now it's like, no, we don't need that, and it's more useful to have names that make sense.
Are actually English words.
Are English words and are something that I would think of, or most developers would think of, like, what is it now? Read line and
print line.
And print line. Yeah, it's like it just makes sense. Yeah, I really appreciate the API.
I'm personally a fan of just read and print myself, but
that's what Python does? Is just like read and print.
Mm-hmm.
Yeah, there is a print, but that one doesn't insert the new line. But maybe that'll be for ZIO3.
Yeah. Okay, so I want to hear a little more about your work in the ZIO scheduler, and I don't know, just for those that probably haven't.
And first, tell us what is the scheduler. What problem does it solve?
Yeah, absolutely. So in a system like ZIO, you have all these different fibers. And each fiber you can think of as kind of a user land thread that has a set of tasks that it's supposed to execute. And you could have a million fibers in a large ZIO application. And for efficiency, you probably only want a number of physical threads equal to the actual number of cores on your system. So maybe
that's the ideal for cache. What's the word?
Concurrency?
No,
like cache locality and avoiding the cost of context switching.
Yeah.
So you have maybe 8 of these threads. And so you need to schedule these fibers onto these different threads. And these fibers may also be doing things where they may suspend at some point. They may go into an asynchronous state where they do some work and now they're done for a while until someone has a result for them and they need to go and they need to wait and then eventually need to get run. And so in ZIO 1.0, we basically just used an executor that is one of the standard Java concurrent fixed thread pools. And what that essentially does is it just has one work queue that all of these threads pull off of. So you can think of every time you offer new work, you just add it to the end of this giant queue, and you have these threads that are just always trying to pick things off of this queue. Mm-hmm. And that works okay. It worked okay for the life of ZIO 1, but there are a couple of issues with it. One, you've got a lot of contention for taking from the head of that queue because you've got these 8 or however many different threads that are potentially trying to get that value. And the other problem you have is you have a loss of that cache locality where you may have part of your computation that you're doing on one of these threads, but then you enter one of these asynchronous states, you submit it to the back of that queue. Well, when it comes to the front of the queue, it's completely random which thread is going to take that. And so you may have a different thread that no longer has that in its cache. And so...
and what sort of impact? I mean, obviously it's a big enough impact that you spent all this time fixing the problem.
Yeah, so it's one of those, I think the benchmarks are hard because to measure it, you do micro benchmarks, and there you can do it very quantitatively. On some of these, it's twice as fast when you do it with this. Now, the micro benchmark is a micro benchmark. When you go and you call some database or you do something over the network, like that adds up really quickly. So for your particular application, you may see that more or less. But one of the things we really want to do is we want to minimize the overhead that an effect system like ZIO brings so that ZIO is, to the maximum extent possible, never a reason to not do. It's never a reason to not do something.
The
in Zio because
efficiency
of
is
performance.
never a reason.
The efficiency is never a reason. Exactly.
Mhm.
You should
Sure,
never
of
have to
course.
take the escape hatch down to some lower level
Right.
primitive in order to work around. the
Ideally, you
efficiency.
don't think about it.
Exactly.
You just go, I will write my code the way I want to write it, and I know it will run efficiently.
Exactly.
Head of line blocking, wasn't that one of the other issues with the where you can get these tasks stacked up behind like one that's taking a long time and consuming all the CPU, and so it gets kind of blocked and can't get scheduled when it could just move to a different thread or something and run, and that would be faster. Wasn't that one of the things you talked about?
So that's more an issue you got to watch out for when you try to improve on this. So like you've got this naive where you have the queue, and there you're okay there because everything's just in the queue. So someone's going to take things as long as there's work to take. So everyone stays busy. That's the advantage of that architecture. But you have this loss of locality and you have this competition. So you kind of think of that as like one extreme of, okay, you have this one shared state of this queue. The other extreme is what you could think of as a completely sharded system. So you could say, I'm going to have 8 different queues. I'm going to have one for each of these threads. And each of these threads is just going to be doing work from its own queue. And when it has new continuations, it's going to put them back on its own queue. And so there you've got almost the opposite set of trade-offs of there's no contention on these queues. There's 100% cache locality, but you create the issue that you raised that depending on work distribution, right? One is just sitting there while another one is backed up.
One queue is empty and one is backed up.
Right. So that model, it's actually the model you see in some either languages or some paradigms, like C* does that. But what that does is it pushes more of the work onto the user to say, how are they going to manage that concurrency of say like, okay, I've got 10,000 tasks. I think these are all roughly the same amount of work. So split them out evenly, or, well, I think these are going to take longer. So give these more weight versus the other ones.
So if something is in a queue, is it always ready to run, or can it be in the queue and in a suspended state?
So if it's a suspended state, it hasn't gone back into the queue. Everything that's in the queue is ready to be run.
Okay, because that's different. I mean, most of my current thinking right now is from Python, and you have a bunch of tasks, and some of them are ready to run and some of them aren't, and the scheduler just kind of randomly chooses them, and if it's not ready to run, it goes and finds another one.
Got it. Yeah. So that model, it can be very efficient, but it pushes this complexity onto the users, which is not the typical experience that you want as a ZIO user. And so
it's not something I want to think about.
No.
Exactly. So the work of this is to kind of try to get the best of both worlds. And we do that through work stealing. So you have those different queues, but each of the threads has the queue that it owns, but it also has the ability to go and try to steal tasks.
So if it runs out of tasks,
it'll get them from the other one.
Somebody else. Okay.
Yeah, exactly.
In which case they wouldn't have the cache locality, but
you're
better
not
than sitting there doing nothing.
Exactly.
Right. Okay.
Yeah. So it's one of those things, it makes a ton of sense. It's easier said than done in a concurrent environment, because you need to make sure that when you take that thing, that it never gets done twice, that you never get into a situation where you think there's not work and then work gets submitted and all of your threads have gone to sleep. So there's definitely more complexity there. But there was some really good work that was done in Rust, in their Tokyo system there.
Okay.
So that was definitely some inspiration for what we did. I think it's worked well so far, and we've got some interesting stuff in the works to build on that further.
Nice.
Yeah.
So I'm presuming that if you're working with the ZIO scheduler and concurrency system, you're assuming that everything is pure functions, so that, in other words, so if I'm in a task and I need some information from another task, I can just read it and I don't have to worry about it changing or me modifying it. Is this in the ballpark?
If the mutability is exposed through like a ref or other higher level constructs.
If there is mutability,
so it's managed mutability.
So
So
it's an effect-based
Yeah.
mutability.
Yeah.
Okay.
Yeah, I mean,
Yeah.
at the level of the scheduler, these are just essentially runnables that it's
Right.
running. So,
It doesn't care about it. I'm just thinking of
but
it.
yeah, ideally it's suspended somewhere, whether
Mhm.
it's a pure function or whether it's a effect that suspends some arbitrary block of code. Yeah.
One of the things that has bothered me with like, I don't know, I did this in Play Framework and other systems where I would have to tell the system this thing is blocking, and so use this other thread pool
Mhm.
for this blocking operation. And I'm like, why am I, the developer, telling you that something is blocking and needs to use a different blocking thread pool? What's in ZIO, like, do you have to, does the developer ever have to designate like this thing needs a blocking thread pool because otherwise it's going to block all the threads? Or
So if you've got something that's literally blocking the thread, then yeah, you want to designate that as blocking with there's just a ZIO blocking operator. You just do it around it and you designate that. We're working on ways to improve that. But when in this environment where you have a limited number of threads, you need to be careful that one of them doesn't just get stuck.
yeah.
And so you have to be careful about how you manage that. And it's challenging, I think, both sometimes from a user as well as from a library author perspective of just identifying what things are blocking.
Yeah.
Because if you can look at a library and you can sometimes not know
Yeah,
as
it's
a
like
user.
yeah, exactly. Like, how do I know if this thing is blocking? Because really, like, what we mean in that sense by blocking is it takes a long time.
Mhm.
Like, because like if something takes 10 milliseconds to run, we probably wouldn't put that into a blocking context. It's like short enough
Well, you
execution.
might not. It depends.
Yeah.
That's the problem with concurrency, is that it all depends, and so you use different strategies for different situations. So 10 milliseconds could be a long time in your program, or it might not.
Well, and it also really matters, is it just taking a long time because it's doing compute work then, or is it taking a long time because it's literally in a thread blocking state? Because if it's doing compute, then okay, maybe from a fairness perspective, you'd like to give someone else a chance to get in, but that work presumably has to be done at some point. You're doing work that needs to be done.
Right.
Versus if you're literally just blocking, then there's other work that could be done by that thread that is not being done because it's in that blocking state.
Yeah. What are the, other than calling like thread.sleep, what are the other blocking things that can block a thread unnecessarily? I guess blocking IO would be another one. But.
Right. It's typically some variant of that, but like if you have a countdown latch and you wait for the countdown latch, anything where there's some asynchronous result and you're like waiting for
I've just been in the reactive world for so long. Like blocking, the only place where blocking makes any sense to me is CPU like heavy computations. Like I don't ever want to see blocking when it's not needed. Like
right. I mean, as a user, you really shouldn't have to deal with it at all. And hopefully, we get to a point where there are more and more ZIO libraries that, if you want to do this type of I/O, you just use this library, and they've thought about that, and they've looked at all these operators in detail and said, is this something we need to shift or not? But probably there are always going to be things you want to do that don't fit into a particular library. And then we want to have better functionality for that. So that's something we're working on.
Yeah. I'll have to look at the code. Remember I was showing you last week the code that I wrote with the ZIO streams? Mm-hmm. And part of the code was using the Levenstein distance algorithm, which computes like the distance between two different strings.
Yeah.
And it's pretty CPU and heavy, but I don't think I put it into a ZIO blocking. But it should be, like, because it's I wonder if I added it, if I put it in ZIO blocking, if that would make any difference from that particular.
Well, if it's just compute intensive, then it's really only a matter of fairness. It's not a matter of correctness. You need to be computing that distance, so you're doing that work. There's no one who's sitting idle there.
Right.
So by fairness, you mean, there's other tasks that should be getting
that
some
should
time.
Potentially getting some time, but that may or may not be important to your application. Right. If you've got if you have 8 cores and you've got 8 of those going on, and you're not seeing that you got a signal from someone that says, well, I don't actually need this distance calculate anymore, that's a problem. If your whole application is just calculating these distances, and you've got to do what you've got to do, that compute has to happen.
Yeah. this is a fun little example that took a file with a bunch of tweets in it, and then it streamed through the file. So it streamed the file and then used the ZIO JSON streaming support and parse tags as a JSON file, and then streamed it through. It did like a moving window through the file to look for duplicate tweets.
Oh, nice.
Using Levenstein distance, and it was I just loved it because it was like so concise. You know, it was like 7 lines of code to like do this thing. But the cool part that I was showing Bruce and Bill was when I run it, all 16 of my CPUs are fully
gone.
maxed. Yeah, and
it's a good sign.
Yeah, it's a good sign, right? So that was a fun one. But okay, so the scheduler stuff is cool. I'm super excited about where all that goes, and it really bothers me when we waste resources. Like we in typical computing, we waste a lot of our resources,
and those could be used for mining Bitcoin.
Yes.
That's what we really need. We'll discover any unused threads you have, and we'll just get those going to work until you have more work.
Create a ZIO library that would do that.
Yeah, you could. Yeah. Or with supply chain attacks, somebody will do it for you.
Yeah. Right.
There you go.
Yeah. So the scheduler stuff is awesome. Yeah, I'm really excited about what's happening there. I had a question about. So Java the JVM's working on that new fiber model thing.
Project Loom.
Loom, that's right.
Yeah.
I always forget the name of it for some reason.
It's also very poetic, right?
Yeah.
The fibers are on the loom.
It is.
Yeah, that'll be a good way to remember it. How does that impact any of this stuff?
So I think it potentially just helps us make ZIO faster, which is great. I think one of the nice things about ZIO is I think it's going to give you a more consistent way that you can develop as we go through this transition. Because essentially what Loom is doing is it's reversing what you're supposed to do. In the old world, in today's world, don't do blocking, right? Never do thread.sleep, never wait for these things. These are all terrible things to do. Yeah. Have everything be callback and async based. And Loom is going to kind of turn that around, and those things where you're just blocking for the result are going to be the fastest things. And so there's going to be, if you're kind of writing that callback based code yourself, there's going to be a lot of rewriting to be done because you're going to have to want to change all that back to a much more traditional style of code.
Yeah.
And so I think one of the value propositions ZIO can bring there is give more consistency to the rest of people who are using ZIO, because essentially when that comes along, we're going to go in and we're going to, in the ZIO runtime, change some of the things we do to take advantage of that and do that. But as a user of ZIO, you're not going to have to do that.
Right.
So I think that's like the first
ZIO's
message there. That
insulate you from having to think about how the fibers and scheduling and all that stuff happens.
And how that's changing. Exactly.
Yeah, and how that's changing.
Yeah.
So you've got a nice isolation layer there.
Yeah. So I think that's the first thing. And then I think the second thing that you may see, and I think this has contributed to this as well as some of the work that actually Bernardowski is potentially doing, is can we eventually get away from the for comprehension? Right. The for comprehension, it's the best way you can express a imperative type, do this, do that, then do this other thing in a functional effect system based style, but it's still not the greatest. And I think we've got to acknowledge the barrier to adoption. There are people who are coming from Java or whatever who are like, this is weird. Why can I not just do val x equals this and this equals this?
So it's not the greatest. What are the problems with for comprehension?
Well, I think the biggest one might just be that it's different than people are used to, right? Okay. If I'm a Java developer and you're telling me like I got to do this thing,
it's calling magical maps and flat maps.
Yeah, a little bit that I've got to kind of explain these are maps and flat maps, and then there are some things that are like not completely regular. Of like, if I'm not in a for comprehension, I want to assign something to a variable, I would do val x equals so and so. But within a for comprehension, I don't do the val, I just do the x. Why is that? And okay, fine, I'm saving some lines, but again, if I don't know it, like that's a little bit weird. Or if I want to destructure something, if I want to destructure a tuple, if I just do val xy equals 1, 2, that works. But if I want to do that in a for comprehension and I've got the arrow there, that's not going to work for me. I've got to do kind of the whole variable in one line. I've got to do an equal to in the next line. So there are all these like little things, and
I think
overall, like
parallelism is another one that I've encountered with the for comprehension, is that because it is like it's just
sequential.
It's sequential, and so there's times where I want to do something in parallel, and the for comprehension obviously doesn't make sense in that case. So
right.
you have to reach for some other mechanism other than the for comprehension.
So what might replace that then? What's the...
Well, so you could imagine some future world where you just assign variables to the results of operations that are effects, and some in the language essentially, along with maybe some of these tools like, I think Project Loom would really be necessary to enable this in a non-blocking way, but it translates that into, you said val x equals ZIO async so-and-so. Well, we're going to say what you really meant there is you meant run that ZIO thing, and once it has its result, assign it to X, and then go on to the next line.
Yeah.
So basically do the logic you were doing in the for comprehension, but do it in a way where that syntax is more familiar to the user.
Could that be done with macros?
Possibly.
There was a Scala project that through macros was doing they were doing it on futures.
Yeah, I think there's one called monadless. I think there are a couple of things there.
Yeah.
So I think there have been a couple of different strands that are potentially connecting that direction of macros, of some of the work that Odersky's doing, of Project Loom, and we'll see if those eventually come together. But I think at some point that could become important. I think right now we're still growing. We've got enough other accessibility issues to solve that's not our limiting factor yet. But sometime, if we're successful enough, that may become the limiting factor.
Yeah. And then maybe we'll have to use the new Scala 3.1 exceptions stuff for the error handling piece, because that's always my concern with as people talk about Loom and being able to do all this async stuff without monads or something like monads, is that you lose the like error channel unless you go back to exceptions or something.
Well, I think the way you ultimately want to go is you don't lose the monad. You just have syntax that makes it easier to work with the monad.
Yeah.
So you're still using ZIO.
Yeah.
You just got syntax that maybe lets you get away from the for comprehension for that. But I think the idea of losing the effect system at all, you get so much else from the effect system. You get errors, you get environment, you get resources, you get much more control over that concurrency of, okay, it's great to like fork things and wait for them, but how about interrupting all of the other things once one thing fails? There's a lot more that goes into that.
Yeah. It keeps popping in my head. So tell me about the fiber tracing stuff.
Yeah, so
that's pretty cool.
Yeah, and it's actually something we're working very actively on this weekend for the hackathon.
Nice.
So it's had a couple of steps. So the first one has been trying to move the work of capturing the execution traces from runtime to compile time. So in ZIO 1, there was this stack tracer that essentially every time when we were running the ZIO interpreter, every time we execute an operation, we would capture a stack trace for it. And we would put those together into the stack trace that would go into, if you ever saw an error and you saw the giant line of all the different failures that occurred, that's where it comes from. And that was definitely a big improvement over the state before that, because before that you didn't really have a trace of what went wrong of the path to failure in asynchronous code, because the stack trace itself didn't give you that information. But it has pretty significant overhead. That's another roughly 2x in micro benchmarks factor. And it's one where, when we show benchmarks, we don't include that. But the reality is the vast majority of people who are using effect systems are using it with tracing because they want to be able to see what happened when something went wrong.
Yeah.
So what this does is it moves that from runtime to compile time. So the downside is if you've used ZIO2, at least in the very latest versions, you may have noticed there's this implicit ztrace element that is on just about every ZIO operator.
Interesting.
And you don't have to do anything with it. It does make the signatures a little bit uglier, and that's one downside there, but it essentially takes away that cost of doing the tracing.
Nice.
Because those are just at compile time, it's just this implicit is just synthesized. There's a macro that captures the information on what the scope is that you're in, and so that's just all was available. And so it both reduces the cost of doing that, as well as it's going to make them a lot cleaner. So one of the things you may have noticed is there were a lot of lines that's like ZIO flat map, ZIO ensuring, and that doesn't really help you. Right. So one of the advantages of this is that for all the internal ZIO operators, we take an existing implicit trace and we just pass that through. Yeah. For user operators, we generate a new trace. And so when you look at one of these traces, you're going to see your code. You're no longer going to see the internals of ZIO.
That's cool.
It's counterintuitive, though. Tracing at compile time doesn't, it's like, but tracing is inherently a runtime activity, it seems like.
Well, so capturing the information on the path we've taken can occur, or that a method gets called from can occur at compile time, but then which one is generated, right? Which one we actually render, because most of them we're not going to do anything with this tracing information because it's just a successful effect. It's the event of failure. We're going to take that information that was generated and we're going to use that.
So you're treating tracing as another effect.
We're being lazy about it. Okay. Yeah. We're being lazy about actually using the traces. Yeah. So that was the work that occurred up to a few days ago. And then the latest is John actually did some really good work that got merged a day or two ago that changes the way those traces are rendered. So they look almost identical to the stack trace that you would get for any Java program.
That's awesome.
And so that way, if you have any tools that are working with stack traces, that are parsing them, those are going to work with the traces that get generated by ZIO. That's cool. And it looks the way that I mean, for better or worse, you've seen a million times the way a Java stack trace works, and now these are going to look the same way.
Oh, and for those that aren't familiar, the amazing thing about this is that it crosses async boundaries, which there's so much code that I'm writing now where it's just, that I've written for the last, I don't know how many years, that's async. And so the stack traces just have no value. And so these, because they're not stack traces, they're fiber traces, now they have actual value across async boundaries.
Yeah.
So just so I'm clear, there's still some runtime overhead for tracing, right?
There's a small amount
but
of
it's
runtime
just
overhead.
super small versus
super small versus what it was before.
Good.
Yeah.
All right.
Yeah.
Nice. Otherwise, it would have been complete magic.
Yes.
Okay.
That's cool stuff. One thing I think a lot about is how we help Java Spring developers move forward into more modern stuff. And I'm obviously so convinced that ZIO is so much better of a model than Spring for so many things. And I don't know, I feel like the Spring community, the users of Spring are just, they so need ZIO. How do we get them to how do we help them?
I think there's another question, which is, for what percentage is it actually possible? I think you need to take that into account. I think there's some percentage where it's not feasible. And so you should say, well, let's look at the people who are and what their needs are, rather than trying to cover everybody.
Yeah. For what percentage? I mean, I would love it if all of them made the switch. How do we make that happen?
But it's similar to what I was talking about before with the study on generics. and that the vast, over 90% of people were just using list of string and map of string to string. They were just putting strings in there, and it's like all the generic mechanisms were just kind of pointless.
Nothing.
So it's like, you're not going to convince that person to, go in this direction.
You don't think I can?
Well, I mean, this is what we're trying to do with the book, but
yeah. I mean, that's kind of the point of the book.
But I think it's still going to be I'm starting to think of it as people who have at least seen a little bit of functional style of programming, even if it's just, using map in Scala in Java 8, or, just, a little bit, that functional thing. I want to know more about that. But I think they have to at least be there before they're interested in reading our book.
Yeah. Well, I think the other thing is having solutions to particular problems. Like, I think Caliban or something is interesting there, of like, look, you want to do GraphQL, like this is a great GraphQL library. This is going to let you write this small amount of code, and you're going to have your client and server. And if that's the payoff, then you're like, all right, well, I guess I got to like figure out like what the deal with this like implicit val I need to define to like make this work. And maybe the first time you do it, to your point earlier, you don't really understand what the implicit val is. You're just like, I guess they told me I need to do this, so this is what I'm going to do, which, to be fair, is what you do with, right? If you use Kafka, probably they tell you, you need to configure it this way, and you don't know all those settings at the beginning, but just do what they tell you, and it works, and you're happy. So you start there, and then if you're like, okay, well, now I guess I've got a Scala application. I guess, what am I going to do with this? And then you start learning things from there. So I think we almost have to like get past the effect system of like, how long in Scala have we spent talking about
I would love to be able to convince Spring users that effect systems are a much better model, and type system based dependency injection is a much better model, and air channels are a much better model. I would love to convince them of those things. And I think maybe to your point, Bruce, like there is a small percentage that will be convinced by those things, but probably what you're saying is true, Adam, that the majority will be convinced because they are trying to solve a particular problem, and ZIO makes it easier
they
to
get
solve.
Stuck in Java or something, and they go, oh my God, this is like an impossible problem to solve. And then they go, oh, I could solve it in this, and it does everything, and I don't have to kill myself.
Yeah.
And that's probably more, that direct experience is more convincing than anything.
Yeah. Yeah, and I guess that kind of matches with my journey through all this stuff too. Is
if you don't know, James will take something and he'll just jump in and try it out without knowing anything about it. That's his favorite way of doing things.
That's a good way to learn sometimes.
It is a good way. It is a good way. I have such a hard time getting there, though. I'm like, no, I have to know all this stuff before it makes sense. James goes, let's just try it and see what we can make. Yeah. And it's really good to.
Really good way.
And maybe that's why I like statically typed pure functional stuff, is because it reduces the churn on bashing through.
No, James, that's not the way to do it. Do it this way.
The compiler just keeps telling me that I'm doing it wrong until I do it right.
Yeah. No,
nice.
It's a good fit.
And that's why I hate YAML, because
oh my God, I indented something. I had one extra space somewhere. It was failing,
and I don't find out. Like, there's no feedback that tells me that I'm an idiot.
But there are spaces now. I mean, we have meaningful indentation in Scala 3 now.
We've been doing for the book just pure braceless,
as pure as possible.
I think it's the future. You've just got to go there, But I think we're getting tooling that when you format, it tells you that, or when it's not indented, it gives you a compilation error. So
that's right.
Yeah. I mean, I think that'll be fine.
Right, which is actually easier than Python, which just gives you a runtime error.
Yeah.
I hate runtime errors. I guess that's a really good way to look at this whole Spring thing, and the way that I'm thinking about it is, like, I wasn't convinced to move forward in my Scala journey because of the technical arguments. And I've been trying to make the technical arguments for why effect systems are important and better to people, and it's not working. And so like
if somebody believes the earth is flat, explaining to them that it's not it just makes them dig in.
Yeah.
Apologies to our flat earther listeners, but we don't think there's more than one or two.
And you've just compared spring users to flat earthers.
I didn't do that. I didn't say that.
Well, I'll go that far and say that. They're basically, if you're doing dynamic wiring of dependencies.
But it's working for them.
Is it though? Because it's not working for me.
They think it's working for them.
They think it's working. I run into so many issues when I'm working on these dynamic applications. It's painful. Just like, come on, give me my ZIO.
But also, are we giving them the solution at the right level, right? Like what you want to use is, people are interested is they want the program to edit their music or to watch their movie. And we're kind of telling them, well, there's a better operating system. It's like, okay, I don't really care about your operating system. I just want to like edit my music file.
Yeah.
And that's what we've eventually got to get to. And I think that's where we're starting to go with, okay, we've got ZIO, we've got a solid foundation. Now we're starting to build other things on top of that are starting to get closer to like the actual problems that people have.
Yeah. Yep.
I think the argument that we're making in the book is that we're not trying to solve the problem of just producing software quickly, which has been the last few decades. How do we make software quicker? We're saying, okay, we can do that now, but it's not reliable software. And so our focus is on reliability.
Mm-hmm.
And if somebody is just saying, well, I did this thing in JavaScript and it worked and I'm able to work, they don't have any pain about it. So I think the pain point is reliability.
Remember, our acronym for the book before we started calling it Effect-Oriented Programming was PREP, because it was combining.
I'm going to correct. That was your acronym.
I still love it.
Yes, we understand.
So it was combining performance, reliability,
expressiveness. I don't know. Something else,
and productivity. So it was yes, we want to build more reliable software more easily, but we also want it to be performant, and that's where like ZIO comes in with amazing schedulers and that kind of stuff. But the other one I was thinking of, which I think we're going to add in another R into prep. I keep saying
you keep saying we. You keep saying we.
Refactorability. So this is something where
Prepper.
Oh
no, that sounds
like that's a different thing.
No, that's somebody who's
already taken.
Yeah.
Let's just not. It is amazing when you go into a code base and can do massive overhauls on it, and the compiler says okay, and then the thing just works.
Or compiler says no.
Well, compiler says no a lot, and then eventually you get it to say,
yep.
Yeah.
My first experience with C++ when I started using it way back when was, oh my gosh, unlike C, if C++ compiles, it works. And of course, that was a stretch, but it was way more than what C would do. Yeah. So, and this is much closer.
Way more.
Yeah. It does what I told it to do, and it does that correctly. It may not be what I wanted it to do, actually, but yeah.
As you know, I've been trying to convince people that the builder pattern is horrible.
Okay.
And the main reason for this is that you only find out at runtime that there's some necessary thing that you've missed or something. And it's amazing how hard it is to convince people that it's a good thing that your compiler should be able to validate as much of the program as possible. Even in the Java community. It's like, I'm like, why is it so hard? Why isn't everybody like fully on board with, yes, let's put as much in the compiler verification as we possibly can?
Because Java works for me and you're attacking it. That's why.
Yeah.
You're saying approach. It's, yeah, you do.
Yeah.
I think so. But, yeah. And I've been, struggling with the whole builder thing, going, what is the issue here? And I think the issue is that it's a stateful thing because it has multiple states as you're building the object. And
mutation.
It's basically visible mutation is what
Brian Getz calls it the ordinality issue or something like that. That when you have a builder and you call something, you don't know. Let's say if it's a list that's the backing like data underneath it, you don't know if calling that thing twice is going to add new things onto the list, or like it doesn't at all express like how the mutations are happening. The builder doesn't express how the mutations are actually happening. Are they being appended? Are they, and so this is where I'm like, gosh, like, yes, the mutability is a problem. The lack of compile time validation is a problem. Anyways, that was quite a tangent into my hate of builders.
It's a hobby horse.
That's a hobby horse.
Or a stalking
Thankfully,
horse.
there are no builders in ZIO. There's no builders, right? I don't think there's any.
Well, I think ZLayer is probably the closest thing to a builder. I mean, hopefully without the bad aspects.
Yeah, yeah, it is like
builds the services that your application needs.
Yeah, at least it's immutable, and you do get compile time feedback if you're missing a layer. And
exactly.
Yeah.
But is that a stepwise process?
Well, the construction, if you have layers that depend on each other, it can be a stepwise process, but that you can think of more as function composition. Of you have a database service that depends on a logging service, and then you have a logging service. So you put those two layers together, and the first one generates the logging service, and then that gets fed into the database and used by the database.
But that's happening, I mean, I guess from the standpoint of the user, is that all sort of an atomic operation? In other words, I say go, I'm not saying take this,
you're just
now later take
data
this.
Structures.
That's all happening. Yeah, you're describing it. You're creating a recipe for building your application.
And then it builds it more or less atomically.
Right before your application
starts. So that doesn't have the problem that
we're
talking about
Right,
here.
But I think the closest, the functional analogy of the builder pattern,
is the Z-layer stuff.
Yeah.
Yeah. What are you excited about in ZIO? What's coming up that is?
Well, I'm excited about getting ZIO 2 out the door.
Yeah.
We've all been working hard, but it's been a while now, and I think it'll be really nice when people can really start using it, because we've been in this little bit of in-between state where people have been excited about it, and there have been for a while now milestones available of ZIO 2, but not necessarily of all the other libraries you would need.
Right.
And hopefully over the next few days, we'll be doing the first release candidate. And along with that, doing a big push to get releases of basically all the ZIO ecosystem libraries supporting ZIO 2, so that you can really take your application. And I mean, I think you're being an early adopter, but everyone can take their applications, and you can take all the dependencies you were working with before, and you can just run them on ZIO 2.
Yeah.
So I think that's going to be really cool.
So what are the changes that somebody will have to do to go from ZIO 1 to ZIO 2?
So basically what you're going to do is you're going to use a Scala fix rule. So Kit did a really good job, and with help from Bill, putting together a Scala fix rule where you basically run this on your code base, and it should generally compile on ZIO 2 after you've run that Scala fix rule.
Sweet.
There's a lot of renaming of, like, put Sterling becomes printline, and so you have to do that renaming, but Scala fix will just do it for you. So,
do you have any favorite features in Scala 3?
I'm really excited for union types. When you do a little bit more, I guess, fancy stuff with types, you find there's a duality between intersection types and union types that we're kind of missing in Scala 2. And so, like with the environment type in ZIO, the intersection of two environment types is exactly what you want and is what's produced by has, and that works very naturally as a type level function of from A to B to A and B. Versus you don't have that other part. You don't have the A and the B to the A or B. And so, like, if you're talking about error types, you can widen the error type, which is what we do in like a flat map, say, on ZIO. But there are times when you want to describe more of a type level function that combines two errors. And in Scala 2, there's really not a good way to say, give me the unification of these two things. Give me the least upper bound of these two things.
Yeah.
And so that definitely comes up a few times as something that we're missing. And so it'll be fun to get to use that, though. I think sometimes the sad part of being the library author is we have to be a little bit slower on some of these things because we can't use a feature that's not going to be supported on Scala 2 until we're really dropping support for Scala 2, which we're pretty far away from at this point.
Yeah, I've seen union types in a number, even Python's type system has added union types. And I think they were talking about putting it in even Java, maybe. I could be wrong about that, but that would be the future sometime.
Yeah, I mean, the sealed traits are kind of sealed classes or whatever, sealed whatevers. And Java kind of, I guess that gives you an emulation of them. But the nice thing that in Scala 3, and even is already working well with ZIO, is when you combine two ZIOs with two different air types, it ORs them right, into a union. It's amazing. The first time we saw this happen, we're like, that didn't just happen, did it? But it was so cool. And then, but the thing that I think you'll be able to take advantage of in the future is how do you then handle one air type, and so that then your ZIO no longer has that
local elimination, right?
Yeah.
Which with the environment as well has been something we've been working on for a while. Yeah.
Nice. Yeah, that'll be cool.
Well, the expressiveness is also really nice. When you see it, you go, oh, yeah, it's this thing or that thing. Just says what it is.
Yeah. Foo or bar. Makes sense. And that's equivalent to bar or foo, which is cool.
It's reflexive.
Yeah.
Nice.
Is that the word for it?
Commutative? I think it's, well,
I'm not.
I
was only a math major.
Yeah, that's right. You should know. Yeah. We didn't worry so much about that stuff in physics.
Well, thank you, Adam. Thanks for all your contributions to ZIO, and thanks for joining us, taking time away from the hackathon to do this with us. Super fun.
Thank you so much for having me. It was a real pleasure.